In this section, we'll be talking about dependent and independent events. Now, when we look at the probability of B given A, and if that equals to the probability of B, now if that's true, we say that B is independent of A. And the opposite is true as well. If the probability of A given B equals the probability of A, that means that A is independent of B. Let's take a quick example to illustrate this. Assume that A is getting a 4 when you throw a die, and B is getting heads when you toss a coin. Now the probability of A given a fair die is 1/6, and the probability of B given a fair coin is 1/2. Now, what is the probability of A given B? Well, it really doesn't matter what result you had when you tossed a coin. The probability of getting any number on a die will be the same. So that means that the probability of A given B is equal to the probability of A. Okay? Now, this is true, as we said, when A and B are independent. Now, we also know that the probability of A given B equals the probability of A intersect B divided by the probability of B. And that's true always. We said here that's true when A and B are independent. Now, since both these equations are equal, we can rewrite them. We say the probability of A intersect B divided by the probability of B, that equals to the probability of A. Or in other words, the probability of A intersect B equals the multiplication of the probabilities, probability A of A times the probability of B. Now, this equation is true only when the two events are independent. We use these formulas for independent events only if it's explicitly stated in the exercise that the events are independent, or if the events are in a context which makes it clear that there's no doubt that they are independent. Let's take an example. A researcher conducts two independent trials. The chances of success in the first trial are 0.7, and the chances of success in the second trial are 0.4. So again, we have two independent trials, and the success in the first trial, the probability is 0.7, and the probability of success in the second trial is 0.4. Now we're asked, what are the chances of the researchers succeeding in both trials? Well, since the events are independent, then we're looking at the probability of getting success in A and getting success in B. Again, since they're independent, we can use the formula for independence, and that's the multiplication of success of the two trials.